Hi, good evening. This is a continuation of the previous session for Unit 3, some tips to remember for you to write a correct planning. Now, there I have mentioned about the key terms that had to be included, and I had described about what they mean, and yeah, I did mention that we'll be discussing a straight line graph. This is very important. Again, sometimes they give you an equation, there is a graph already plotted and you're doing some calculations, or in your experiment itself you will be expected to draw the sketch of the graph from the particular equation given and so on. All right, we'll see how to go about it. Now say I've not mentioned any quantity here, just randomly we have taken A is equal to BD over C square. That's the equation given to you, and they've asked you to write a planning for finding a relationship between two quantities. All right, say if the two quantities are A and C, okay, you have to establish a relationship between A and C. So how would you proceed? As I told in the previous experiment, you have to look into the practical possibility of increasing which quantity of the two would be easy for you to increase it in equal intervals, which can be controlled easily, that you will keep it on the x-axis. All right, so say if I have A is say C is easily controllable for me, then I would prefer to take C on the x-axis, or C to be the independent variable. Okay, so C is my independent variable and A is my dependent variable. So I fixed that. So this must be mentioned in your planning. After this, what do you do? Now, in the previous one, I've explained how to record readings, how many readings you should take. Minimum of 7 set of readings you must take for you to plot a graph accurately. Reason being, at least 5 points you need to make a valid straight line or a curve graph. Minimum 5 points. So for that, you need to be on the safer side, you just take extra 2 readings. All right. So to plot a graph, ideally you should have taken 7 set of readings, and then take repeat readings, take average, so that you're sure that you have reduced all those errors and your readings are almost, I would say, accurate. All right. Then, so you have gotten this in your table, you have got A on your table. Okay. Then what do you do? Looking at the equation, we don't have A and C directly, right? Now, as I told you, these quantities are not familiar to you. You're not sure whether it is going to be a straight line or not. So how do we get it from the equation? The trick is, what you do, square this C square, all right? Because you have got C square in the equation. Then look for B and D. What are these quantities? All right. If these should be the control variables. I've mentioned it in the previous one. So if these two quantities will be a constant throughout this experiment, all right, say if one was acceleration due to gravity, the other one was coefficient of viscosity, that means these two cannot change during the unless the temperature changes and so on, right? So the measures and all you have taken, and you're sure that these two are constant. Then also, will A and C, if I plot A and C here, will it be a straight line? Will you be sure? You're not. But what you can be sure is, if you plot, say A is your dependent variable, so A must come on the x-axis. Now C should be on the y-axis. But instead of C, what I would do is, I would plot 1 over C square. I'll tell you the reason. Now A equals 1 over C square, I'm going to split into, since that's in the numerator, BD. Now this is constant, right? Now, what's the straight line equation? Y equals mx plus C. That's your standard straight line equation, correct? Now the equation that you are analyzing, if you can bring it to this form and establish, when will this equation give you a straight line passing through the origin? When the C is equal to 0, because C stands for y-intercept. So if y-intercept is equal to 0, then the line should pass through the origin. So look at this equation. You've got one expression. you do not have any other expression. That means it will not have a y-intercept. So this graph, you are going to get it passing through the origin, provided if this is equal to m, which has to be constant, then 1 over c square is equal to x. So the graph that is plotted between a and 1 over c square will give you a straight line passing through the origin. But if you plot a and c, you will not get. Right? I'll write it again. So from this, so your a is on alright, from here, so I remove that a. Now this a is equal to y in my equation, right? So a, if I plot on y, and 1 over c square, which is like x here, alright, that has to be plotted 1 over c square here. This graph will lead to a straight line passing through the origin. You get it? So how is the analysis done? As I said, first identify C and A. C has to be plotted on the x-axis, A has to be plotted on y-axis, but then directly you will not plot it. You can, it's not wrong, but then for you to analyze the graph easily, if you are trying to find out one of the variables here, if that's the aim, one of the question, to find g from the graph, from the experiment, acceleration due to gravity, g is the question, then you have to calculate the gradient and then insert it in the equation. All right, for that particular analysis and all, or similar analysis, it's better to plot 1 over c squared and a, so that you get a straight line passing through the origin. I hope it's clear. Then, so I'll write again. So this is a equals, I'll write BD first, because BD is the coefficient of x. Okay, there is no c term is 0. So if you compare this with y is equal to mx, this is y. These two terms together will be m, and this is your x. Getting it? So y is equal to m into x, as I said, plus c, that's 0. Then if you want to calculate one of the quantities from here, what would you do? You calculate the gradient from here, y over x, and gradient will be equal to, say if you're getting 0.5 as your gradient, that could be equated to b into d. So if the coefficient of viscosity, whatever, one of the quantities is known to you, substitute that and get the value for the other term. I hope it's clear. So I repeat, first identify independent dependent variable, then construct or reconstruct the equation so that it's in the form of y is equal to mx plus c, and if there is any square term, plot or separate that from the rest of the terms, equate it to gradient, and try to explain it clearly and plot an expected graph in your, if you include in your planning, that adds more, you are in a better position to secure full marks. All right, all the best, and see you in another video.